recognizing rational and irrational numbers. Okay, in this diagram, you need to determine if something is rational or irrational. Well, what is rational? What is irrational? Well, it's easier to explain irrational. Irrational is something that is, let me write this so we remember what I'm talking about. Irrational is the square root of 7, because this is numbers that go on forever and ever and ever and ever. It never repeats. It never terminates. Another example of irrational is pi. Another example of irrational would be their first example, the cubed root of 15. That means what number times itself 3 times will give you 15. And again, it's not, you don't find an answer. You do it on a calculator, and all of the digits would line across the calculator screen. So it does not terminate, and it does not repeat. So the cubed root of 15 is irrational. The square root of 15 is irrational. 3/15, that is a fraction. A fraction and a decimal that terminates or repeats is rational. So 3/15 is rational. And 0.15, that's a repeating decimal. So that is rational. All right, let's take a look at some more. The square root of 32 is irrational. It is a decimal number that goes on forever and ever and ever and ever. Rational, number 9 is rational. 7.11, rational. 6.5, rational. 11 times pi, again, pi is irrational, so that answer would be irrational. Next one, the square root of 7 is a decimal that goes on forever and ever and ever, and it never repeats, never terminates, so that is irrational. 4 pi, irrational. 3.2, that's rational, it can be written as a fraction. 0.45 can be written as a fraction. 0.245, repeating with the 5, can be written as a fraction. So those are rational. 0.7 pi, because it has the pi in it, it is irrational. 7/11 is rational. Number 7, that's a repeating decimal. That is rational. 0.7, repeating decimal, and terminating decimal. Okay, so the only one there, irrational, is with one with the pi. -3/7. Doesn't matter if it's positive or negative. That has no bearing on whether it's irrational or not. It can be written as a fraction. 0.6 repeating, rational. Now, some of you look at the square root of 1/4 and you're thinking, no way, that has to be irrational. But what is 1/2 times 1/2? That is 1/4. So the square root of 1/4 is equal to 1/2. 1/2 is rational. So that one is rational. The cubed root of 125, 5 times 5 times 5 is equal to 125. So the cubed root of 125 is equal to 5. 5 is rational, so the cubed root of 125 is rational. The square root of 66, that goes on forever and ever and ever, doesn't repeat, doesn't terminate, so that is irrational. Good luck.